Welcome back, geometry students, to another Regents review video. This is going to be the August 2015 Geometry Common Core Regents exam. This video is going to be parts 2 through 4. These are the open-ended short response questions for the Geometry Common Core exam for August 2015. And if you see my other videos, I will tell you that the part 2s, 3s, and 4s for geometry is a lot longer. This video will be long, and I apologize in advance. But we have to do what we have to do. It takes a long time to explain these things, but I hope that you bear with us throughout the whole process. If you're here to copy my answers and hand them in for homework, or to get a test done, or something like that, you're wasting your time because the Geometry Regents is so incredibly difficult, and I want you guys to do well. So please, refrain from doing so. Do not watch this if you didn't get it done. If you're here to check your answers, or if you need a little bit of guidance, you're in the right place because I am here to help you. Without further ado, we're going to go right into the part 2s. I don't want to waste any time because this will take a long time. Starting off with question number 25. A wooden cube has an edge length of 6 centimeters and a mass of 137.8 grams. Determine the density of the cube to the nearest thousandth. And then it says state which type of cube... It says state which type of wood the cube is made of using the density table below. So there's one formula that you need to know in order to start this process. Density is equal to mass divided by volume. Honestly, I don't know why this is in geometry, but it should really be in a science class, but we're teaching it anyway, and I don't know why we are, but, you know, whatever. Now, define the volume of a cube, because this is a cube, and remember that a cube is just a little block. That's all it is. The volume of a cube is length times width times height. So to find the volume, that's just going to be 6 times 6 times 6, because in a cube, all edge lengths are congruent. So the density is equal to the mass, which is given to us, which is 137.8, divided by 6 times 6 times 6, which is 216. So that's approximately equal to 0.638. So we just found the density. And to compare the block, that is going to be ash. So your block of wood is going to be ash. All right. Moving on to 26. Now, I just want to talk about this construction for a second. If you don't like my computer software that I use to show the construction, you could fast forward a little bit. I actually do a hands-on construction immediately after this one. So if you just want to skip it, I totally understand. But if you want to watch me do both, stick around. So it says here, construct an equilateral triangle inscribed in circle T shown below. So I'm going to walk you through the steps. All right, so here are the steps to get this right. Number 1, you need to measure your radius. That's step 1. Step 2, then, is start at the point of intersection, or start at the point and measure around. Okay? And this will all make sense in a moment here. And then step 3 is going to be connect every other point. So, this is what we have to do. First of all, you need a compass and a straight edge in order to complete this. Here's my compass, and here's my straight edge. So I'm going to take my straight edge, and I'm going to place my straight edge on T and measure the length of the radius. The intersection point where that is, I'm going to call this point, point A. All right? Now, you don't have to do that, and you also don't have to measure. You don't have to show the radius. You could just go right into the construction. But I just do it anyway just so I know that I am accurate. So, I am going to place my compass point on T and measure it once more. And that is the length of my radius. Do not change the compass setting at all. You are then going to place your compass point on A. And then you are going to begin measuring around. So I'm going to draw an arc. And I continue the process all the way around the circle. So once I measure that one, I have to place my compass point on the new arc and then do it again. Like that. And now we're just going to continue the process and repeat the steps that I just said to do. Now, what's nice about this construction is if you have a point and it meets up very close to the diameter, you're in pretty good shape. Because in theory, your last arc is supposed to swipe point A. And we're going to keep on going around. So place my compass point again on here. That's my point. Do it again. Keep on going around. Do it once more. And then my final arc, I'm going to swipe it across. And hey, what do you know? It's pretty darn close to point A. So now I said connect every other alternating point in order to construct an equilateral triangle. So every other point means this, ladies and gentlemen, right here. And that is how you construct an equilateral triangle. All right. So the next piece of this video is to show a more hands-on construction on how to construct this equilateral triangle. If you don't want it, you can just fast forward to question number 27. All right, so here's number 26 from the August 2015 Regents exam. This is the construction. And this is for people who don't like the smart notebook software that I use. This is just a more hands-on construction video. So it says here, construct an equilateral triangle inscribed in circle T shown below and leave all construction marks. So remember, to construct an equilateral triangle inscribed in a circle, we need to measure the length of the radius from point T to the end of the circle. So the first thing that I'm going to do is I'm going to take my compass and I'm going to measure the length of the radius, which is right there. As you can see that I just measured the length of that radius. All right, so I put my compass aside and I don't touch it. What I then do is I take my ruler or my straight edge and I connect from one end point of the circle to its center and I create a radius. And I'm going to call this point point A. You can call it whatever you want. Now, you don't have to draw the radius. I just like to do that just so I know for sure that I measured it correctly. So once again, you place your compass point on T. Make sure that you measured it correctly. Now we're ready to begin the construction. So we place our compass point on A. And what we're going to do is we're going to swing around all around the circle to create an equilateral triangle. So I'm going to swing my compass one time. This arc is now the arc where I place my compass to find the next arc. So I place it over here and I continue the process. Now, precision is very important to get this construction right because it's very easy to lose the distance around and you'll go past A. You're supposed to meet up back at point A at the very end of this construction. So now, once again, I place my compass point on the new arc and I repeat the process. Now, if this point lines up well with the diameter, we're off to a good start, and so far it does. And let's keep on going. There's my fourth arc. Here's my fifth arc. And last but not least, here is my sixth arc. And it's pretty darn close to A. So that would be acceptable on the radius. If it goes a little bit more than A, that's perfectly fine, but it's really supposed to be on A. But they do give a little leeway if that were to happen. So now, if we're trying to construct an equilateral triangle, remember that a triangle has three sides. Your job is to connect every other point, or the alternating points. So now I just drew those 3 points in, and now I'm just going to take my straight edge and connect all 3 of these points. And these are the vertices of the triangle. And there you have the construction on how to construct an equilateral triangle. All right, next question. Okay, question number 27. To find the distance across a pond from point B to C, a surveyor drew the diagram below. The measurements he made are indicated in his diagram. Use the surveyor's information to determine and state the distance from point B to point C to the nearest yard. So that's going to be my X. Ladies and gentlemen, this question has such a common mistake, and I cringe and I bite my tongue every time this happens. These two triangles are similar by angle, because that angle A is reflexive in these two triangles. So what you have to do is you have to set these two triangles in proportion. But in order to do that, you need to understand, hey, wait a minute. I need to add these. because that's my full side of the triangle. So this is going to add up to 315. I cannot tell you how many times I saw this mistake. I see the same mistake all the time. Don't write this down, please. I see this all the time. 230 over 120, 85 over x. No, do not do that. 85 is too short. That's a trapezoid down there. That's not a triangle. So what we have to do is we need to say, okay, 230 over 120 is equal to 315. Over x. That's how you do it. Now you just cross multiply. You get 230 is equal to 37,800. Sorry, that should mean x after the 230. And then we divide by 230 on both sides. And then you get x is approximately equal to, what is that, 37,800 over 230 with a decimal point. 164.3, rounded to the nearest yard. That's approximately 164 is your answer. Moving on to question 28. In parallelogram ABCD shown below, diagonals AC and BD intersected E. Prove that the measure of angle ACD is congruent to the measure of angle CAB. Now, the one thing that you need to understand is, because it says prove, that doesn't mean form a statement, reason, proof column. It's just saying prove. I actually answered this question in 2 sentences. And how do we prove these to be congruent? Well, in a parallelogram, you should know that opposite sides are parallel, and these angles here are alternate interior angles. So I'm going to say this. In parallelogram ABCD shown, DC is parallel to AB because in a parallelogram, opposite sides are parallel. Pretty straightforward so far. Now I'm going to say that angle ACD is congruent to angle CAB because, and this is where what will get you the full credit here, because if 2 parallel lines are cut by a transversal, then the alternate interior angles are congruent. And that will give you the full 2 points. Just 2 very basic, straightforward sentences will get you full credit on this question. Moving on to number 29. Triangles RST and XYZ are drawn below. If RS is 6, ST is 14, XY is 9, YZ is 21, and the measure of angle the measure of angle S is congruent to the measure of angle Y. Is triangle RST similar to triangle XYZ? Justify your answer. Well, if they're similar, then the sides are proportional. So are these two sides are these 2 pairs of sides proportional to each other? Well, let's set up a proportion. Is 6 over 14 equal to 9/21? Well, what's nice about the TI Inspire is if you go to your calculator and you type in 6 over 14, and there's an equal sign here. The equal sign is right underneath the control button, and if you click on equals and then you type in control division again, 9 over 21, it will actually tell you if it's true or false. Hey, it's true. So these are proportional. That tells us that they are proportional because it is the exact same ratio. And angle S is congruent to angle Y. So to answer the question, are these 2 triangles similar? Yes. And justify your answer by side angle side similarity. And that's it. That's how you prove those 2 triangles similar. Yes, by side angle side similarity. Pretty simple question. Moving on to number 30, one of my favorite questions because it's all over the place. In the diagram below, triangle ABC and XYZ are graphed. Use the properties of rigid motions to explain why triangle ABC is congruent to triangle XYZ. Okay, so what you need to say is, well, first of all, what is going on here? It looks like a rotation of 180 degrees. or it's a reflection over the x-axis followed by a reflection over the y-axis. So we're going to say that triangle ABC is congruent to triangle XYZ because a rotation is a rigid motion. That will give you 1 point. If you could state that a rotation is a rigid motion first, that gives you a point. This is your second point where it comes from, which preserves distance and congruency. That will give you full credit on this question. Ladies and gentlemen, I want to address one issue that many people have. If you said in your answer, a rotation is a rigid motion which keeps the size and the shape, I cannot guarantee that you will get full credit. The state of New York, the New York State Education Department, wants you to use mathematical vocabulary. That's new to the Common Core. They want you to say distance and congruency. We are big boys and girls now. We cannot say size and shape anymore. You have to say distance and congruency. Now, that doesn't mean go run and tell your teacher, hey, you're teaching this wrong if they taught you size and shape. It just means that change up the vocabulary a little bit to make your answer sound more sophisticated, because that's what they want on this exam. And I saw it in the model response set that the state releases, and they want distance and congruency. All right, moving on to question 31. Now, teachers teach this type of question differently. I teach it very differently. Number 31 says the endpoints of line DEF are D14 and F1614. Determine and state the coordinates of point E if the ratio of DE to EF is 2 to 3. Now, you need to know two formulas. Many teachers, how they teach this topic is they teach you how to graph it. I do not like that, because as you can see on this question, there's no graph paper. How are you supposed to graph it? Yeah, you could go to the back of the Regents and graph it, but on the top it says this sheet will not be scored. They're not supposed to be scoring that back there, but if they do, that's their decision, meaning that the teachers grade it. So what I say is nope, don't even do that. I say, all right, go ahead and memorize these formulas. And I know they're like, oh God, it's another two formulas to memorize. They're really not that bad. Okay, you just have to memorize these for your Regents, and you will be good to go, because this question is on every single test. All right. Those are the formulas. X minus x1 over x2 minus x is equal to the given ratio, and y minus y1 over y2 minus y is equal to the given ratio. They are very similar, but they have nothing to do with each other. They are not the same equation, because one of them is for the x value, one of them is for the y, and the other is for the y value. So you see how point D, it says that point D is first. This is your x1. This is your y1. This is your x2. This is your y2. We're going to plug in that information. So we get x minus 1 over 16 minus x is equal to the given ratio of 2/3. Okay? Now from here, we are going to cross multiply. So we get 3 times x minus 1 is equal to 2 times 16 minus x. Continuing on with the process, we are going to distribute this. We get 3x minus 3 is equal to 2 times 16 is 32 minus 2x. We're going to add the 2x on both sides, and we're going to add the 3 on both sides. Those cancel, those cancel. We get 5x is equal to 35. Divide by 5 on both sides, and we get x is equal to 7. Not too bad. Let's do it for the y value. Your y1 is your 4, your y2 is your 14. You keep the y's there, because that's supposed to be there, because that is your variable. Y minus 4 over 14 minus y is equal to the given ratio of 2/3. We're going to cross multiply. 3 times y minus 4 is equal to 2 times 14 minus y. We are going to distribute these. We get 3y minus 12 is equal to 28 minus 2y. Add the 2y on both sides. We get 5y, and we're going to add the 12 on both sides too. We get 5y is equal to 40. Divide by the 5 on both sides, and you get y is equal to 8. So, ladies and gentlemen, that will give you 1 point on your Regents, and it says actually state the coordinates to get your full points. You have to say that E is 7, 8, and that will give you full credit on this question to state that E is the point 7, 8. Not too bad of a question. Now it gets worse. We're now in the part 3s. They're a little bit more in-depth. They're not hard, but they're more in-depth. And this is a trigonometry question. Number 32 says, as shown in the diagram below, a ship is heading directly towards a lighthouse, whose beacon is 125 feet above sea level. At the first sighting, point A, the angle of elevation from the ship to the light was 7 degrees. A short time later, at point D, the angle of elevation was 16 degrees. To the nearest foot, determine and state how far the ship traveled from point A to point D. So, we're trying to find this. That's X, from point A to point D. Can you use any mathematics that could solve for AD without even using trigonometry? No. You cannot solve for AD just by itself. You have to use trigonometry to get the length of AD, and I'll show you why. We could calculate the distance from D to C. I'm going to call that Y. And we could calculate the distance from A to C. I'm going to call that Z. And the reason why is that this big triangle is a right triangle, and this little triangle over here is also a right triangle. So I am going to calculate the distance of DC, but keep in mind that that's a right triangle. And I also know that this over here is a right triangle. Why did I pick these colors? That is disgusting. I'm going to put it under here. All right, there we go. So let's calculate the distance of Y first. So calculate the distance of Y. To find the distance of Y, I need to calculate, I need to figure out what to use. Well, first and foremost, I need to use SOHCAHTOA. That's number 1. This angle over here, that's 16 degrees, is your reference angle. Your opposite side is 125, and your Y is your adjacent. So if this is your opposite, and if this is your adjacent, we have to use tangent. So we're using the tangent of some angle is equal to the opposite over the adjacent. Now, the tangent, we're using the tangent of 16 degrees. That's your reference angle, which is equal to the opposite side, which is 125, over the adjacent, which is Y. You're going to put tan of 16 over 1, and you're going to cross multiply. So we get Y tan of 16 is equal to 125. We're going to divide by the tan of 16 on both sides. And you get Y is approximately equal to 435.9628. Do not round, please. Now, to calculate the distance of Z, you're doing the exact same thing. You're also using tangent. This is a double tangency question. The minute you start seeing triangles overlapping, it's a tangent question. But it changed a little bit this time. We're now using the 7 degrees because we're now in the bigger triangle, the green triangle. So you have the tan of 7 is equal to the opposite, which is 125, over the adjacent, which is Z. Okay, put that over 1 and solve. So we get Z tan of 7 is equal to 125. Divide by the tan of 7 on both sides. And we get Z is approximately equal to 1018.0433. Just type that into your calculator and you'll get that. Now, to find the distance of X, X is equal to the Z value minus Y. To calculate that little guy right there, it's the big piece minus the little piece. So that is going to be X is equal to 1018.0433 minus 435.9268. And that will give you approximately 582 feet. It says round to the nearest foot. That is your answer, ladies and gentlemen, 582 feet. All right, moving on to question 33. This was definitely an interesting question. It says triangle ABC has the vertices with A as x3, B -3, -1, and C -1, -4. Determine and state a value of X that would make triangle ABC a right triangle. Justify why triangle ABC is a right triangle. So you have to use your graph paper because the graph will help you. I promise. First thing that I'm going to do is I'm going to start graphing these points. I'm going to graph the point -3, -1. That's your point B. C is -1, -4. Cool. And I'm going to connect these 2 points. That's the line BC. Now A, I want to talk about A for a second. X comma 3. We got to find the value of X that would make this a right triangle. Well, what's nice about them is they gave us this. That's your Y value. Ladies and gentlemen, your point has to lie somewhere along the line Y is equal to 3. It has to be somewhere on this line. And if it's not, then you have problems because you have to get that fixed immediately because it has to lie on the green line. So the slope of BC, okay, in order to make a right triangle, you need to have perpendicular lines. And perpendicular lines have negative reciprocal slopes. So the slope of BC is down 3 to the right 2. So that's down 3 to the right 2. Your slope of AB has to be the negative reciprocal of -3/2, which is equal to 2/3. So starting from point B, I'm going to go up 2 and to the right 3 until I reach the green line. So go up 2 to the right 3, up 2 to the right 3. Oh, wait a minute. I just got that. So that point right there is the intersection point. So A, just read off the X value. 1, 2, 3 to the right. 3, 3. So your answer is X is equal to 3. Justify why it's a right triangle. You could say because BC is perpendicular to AB, which forms right angles. Okay? That is your answer. X is equal to 3. Now, there is another answer. If you actually go up 2 to the right 3 in the other direction. But I will tell you right now, it is much more complicated. Because if you keep on going up 2 and to the right 3, look what happens. Up 2 to the right. Oh, shoot. You're off the graph now. Could you draw a rough estimate? Yeah, of course you could. But that intersection point that you see right here, that is X is equal to 9.5. So if you indicated 9.5 as an answer, that is also acceptable. Okay? So there's two answers, 3 and 9.5. 34. In the diagram below, AC is congruent to DF, and points A, C, D, and F are collinear on line L. All of a sudden, they're making up a triangle. Let D prime, E prime, F prime be the image of triangle DEF after a translation along line L, such that point D is mapped onto point A. Determine and state the location of F prime. Explain your answer. So, they're saying that they're creating another triangle. And the triangle is triangle DEF. So it's being translated along line L. So it says that, what does it say? Point D is mapped onto point A. Nice. So therefore, we have this triangle right here. So D is being mapped onto A. So therefore, F is mapped onto C. But this is D prime, E prime, F prime. It's asking you for the location of F prime. Well, where is F prime? At point C. So we're going to say that F prime would be located at point C because a translation preserves distance and congruency since it is a rigid motion. And the key word in this whole sentence is congruency. Congruency means that you can map the same points onto each other. F maps onto C, which is F prime. So congruency is key to the answer explanation. So that will give you full credit. Then there's a follow-up question. Then all of a sudden they make up another triangle. Let D double prime, E double prime, F double prime be the image of triangle D prime, E prime, F prime, which we created after a reflection across line L. Suppose that E double prime is located at B. Okay, well, let's reflect it. Here, here, and here. So it says that, what did it say? E double prime is located at B. E double prime is located at B. So this is E double prime, this is D double prime, this is F double prime. Now it's saying all of a sudden, is triangle DEF congruent to triangle ABC? So is this triangle down here, which is triangle ABC, is that congruent to this one? And you should be screaming in your head, yes it is. Yes it is. Because there was a sequence of transformations that are rigid motions. So we're going to say, as an answer, yes, since both a reflection and translation, both a reflection and translation are rigid motions. This is a good rigid motions question, that's for sure. Are rigid motions which preserves distance and congruency. And that's it. That's how you do that question. Okay. Moving along to the part 4s. Now, the part 4s are extremely in-depth, folks. So please bear with me. We are almost done, I promise you. First and foremost, this is a statement reason proof. So I'm going to type out statements and reasons, and I'm going to create a T table or a statement reason chart. If you want to fast forward this, that's perfectly fine with me. But right now, I want you to start thinking about how can we prove, how can we prove this thing, or parallelogram ABCD to be a rhombus. So things should start jogging in your head like, oh, a rhombus has 4 congruent sides. That could prove a rhombus. Or, oh, I know, diagonals are perpendicular in a rhombus. That could prove it. So we need to come up with a plan right now. And here's our plan. It says in the diagram below, it says parallelogram ABCD with BE being perpendicular to CED. Okay. And DF being perpendicular to BFC. And CE is congruent to CF. Prove that ABCD is a rhombus. Okay. So a couple things. You know, or you should know, that you have to be proving triangles congruent somewhere. These 2 triangles that you see here, so triangle, actually I'm going to change this. I'm going to change it to yellow. Triangle BEC is congruent to triangle DFC by angle side angle. Where's that other angle coming from? Angle C is reflexive. So the plan to prove this to plan these 2 triangles congruent is by angle side angle. But what does that do for us? Well, in a rhombus, adjacent sides are congruent. We could prove that this side is congruent to this side by using CPCTC. Let's talk about it right now in our proof. Number 1, I'm going to list all the givens. So I'm going to say parallelogram ABCD. BE, you could skip this if you want to. I'm just listing the givens here. CED, DF is perpendicular to BFC. CE is congruent to CF. Number 1 is given. Okay. Number 2, I'm going to say this is angle 1, this is angle 2. I'm going to say that angle 1 and angle 2 are right angles. The next logical thing to say is perpendicular lines form right angles. That's your reason. Now, for number 3, you need to state that they're congruent. So angle 1 is going to be congruent to angle 2 because all right angles are congruent. Next, I'm going to say number 4, I'm going to say that angle C is congruent to angle C. Your reason is the reflexive property or the reflexive postulate. Either one of those is fine, doesn't really matter. Now, one thing that you have to look out for is We already proved our side length. That's here. We just proved it. CE is congruent to CF. That is our side. We don't need to state it again because we already have it. Number 5, I'm going to say that triangle BEC is congruent to triangle DFC. And your reason is angle side angle is congruent to angle side angle. Now we're done proving the triangle's congruent. So what I like to do is I like to draw a nice squiggly line down here. You don't have to do this, but it just separates one from the other. Now we could say that BC is congruent to CD. Your reason is CPCTC, corresponding parts of congruent triangles are congruent. Once you prove that by CPCTC, we can now officially say that ABCD is a rhombus. And your reason is, two consecutive, meaning next to each other, two consecutive sides that are congruent in a parallelogram proves a rhombus. And that, ladies and gentlemen, is your proof. We just proved this to be a rhombus because if you have two adjacent or consecutive sides that are congruent, it has to be a rhombus. Last question of this video. 36. Walter wants to make 100 candles in the shape of a cone for his new candle business. The molds shown below will be used to make the candles. Each mold will have a height of 8. Okay, 8. And a diameter of 3. That means that there's a radius of 1.5. I don't care about the diameter because, you know, they tell us the one thing and then we have to conclude that what the radius is because we need the radius in the formula. But the diameter is 3, so the radius is 1.5. To the nearest cubic inch, what will be the total volume of 100 candles? So this is in a cylinder, or this is a cylinder. So what will be the total volume of 100 candles? So the volume of the cylinder itself, because it's saying what would be the total volume of 100 candles. So it is the volume of the cylinder, which is the volume of the cone, I should say. The volume of the cone is 1/3 pi r squared times the height. We don't want the volume of the cylinder. We want the volume of the cone. So the volume is equal to 1/3 pi times the radius of 1.5 squared times the height of 8. When you type that into your calculator, you get, let's see, 1/3 times pi times 1.5 to the second times 8. And that will give you 18.849. So the volume is 18.85 I'm sorry, I just rounded it. That's fine. You could round it now because it says to the nearest cubic inch. Now we're going to multiply by 100 because that's the volume of one candle. We need the volume of 100. So 18.85 times 100 candles, that would be 1885. That would be the total volume of 100 candles. You do not need to indicate units on the geometry readings, by the way, so that would be an acceptable answer. Now it says Walter goes to a hobby store to buy the wax for the candles. The wax costs 10 cents per ounce. If the weight of the wax is 0.52 ounces per cubic inch, how much will it cost Walter to buy the wax for 100 candles? Hold on a second. If the weight of the wax is 0.52 ounces per cubic inch, how much will it cost? This is a classic example of weight is equal to density times volume. Yes, it's back again. I think that's like the third time on this Regents that it tested you. Weight is equal to density times volume. The weight is equal to the density, which is 0.52, times the volume. Well, we just found the volume. It's 1885. So the weight is going to be 980.20 ounces. Okay? Now, to find how much the thing will cost, it says 10 cents per ounce. So just take the 980.2 ounces and multiply it by 10 cents, or 0.10. That will give you a total of $98.02. cents. Okay, that's how much Walter will spend in the hobby store. Then it says if Walter spends a total of $37.83 for the molds and charges $1.95 for each candle, what is Walter's profit after selling 100 candles? Okay, this is kind of like accounting or banking. Profit is equal to revenue minus expenses. You need to have a little bit of common sense and a little taste of reality. And if you don't know that profit is equal to revenue minus expenses, ask your parents. So, revenue. Revenue is how much money you earn. Expenses is how much you spend. The profit is what you put in the bank. For example, if you go and if let's just say you own an amusement park and you make $1 million by selling tickets. Your revenue is your revenue is $1 million. Your expenses are buying the food, hiring the employees and paying the employees, making sure that the rides are in standard and operating condition, making sure that everything's paid for. Your profit is what you actually bring home. So expenses could be $500,000. So it's $1 million minus the $500,000, and you go home with $500,000 or $500,000. That's what's going on here. So to find his revenue, we take $1.95 for each candle that he sells and multiply it by 100. So that will be the revenue. Okay? So profit is equal to the revenue, which is $1.95 times 100 candles minus the $37.83 that he spends on the molds. So the profit is equal to $59.15 is how much profit he is bringing home for himself. And that is the conclusion of this Regents exam. I hope that I helped you. Please visit www.nysmathreadersprep.com for more math content, and please hit the subscribe button down below, and make sure that you use these videos in the future to help you in math. All right, I'll see you soon.